Hey everyone, welcome to the channel. Let's start learning about cross entropy loss. Cross entropy loss is something like a mentor to Softmax so that it kind of punishes it for giving wrong predictions. If the prediction loss is zero, that means we didn't deviate from the true value, so that will be the same values in both sides, that will be a zero. And cross entropy loss is a simple loss concept. For this, you need to understand what loss log is really is entropy is. Entropy is actually the randomness that is introduced, and cross is like between two values. So before that, let's learn what log is. Log is basically the counterpart of e exponent. If you don't know what e is, in the last video it is explained. So let's E is the natural limit one can achieve, and log is something like at what point you can. I mean, the amount you need, the amount of time or the amount of experiments you need to arrive this natural point. So in simple terms, if you take 10 rupees loan for 2 years, and some, let's say you ended up with 100 rupees at the end, this will be the e. And if you want to know how many years that I ended up with 100, that will be log. And log is the concept here, that using this we'll just calculate the loss and change the values we got in the softmax. That means the exponent values. If the value we need has more loss, we'll just improve that e value of it, and if other values are wrong, we'll just decrease other parameter values, so that it will be easy for us to evaluate at the end. There are two types of cross entropy loss. One is binary and other is categorical. Binary is basically yes or no, or one or zero. For this, you need to understand what probability is, and for categorical, there will be different kinds of data. Like you have different kinds of choices from a different array. Let's say you need to find a dog, then you'll have options like dog, cat, tiger. So you can't arrive at a single solution, but it has a solution. If you want to find a dog, that the true value will be dog. But in binary, you have to end up with either yes or no. So there will be a little difference between these. And the end goal of this loss formulas is to find the mean and check how good the softmax values we have. That means how good this array is. And let's see what these formulas are about. Okay, before that, you need to remember what probability is and what formulas we have there. If the probability of something happening y, but something not happening is 1 minus y. So this is similar to 0 and 1 for our case, but mathematically it is wrong. And what we do in binary is we'll just take the negative mean of these two values under a log condition. So yi is the true value. That means the yi here, that's the value we need. It can be 0 or 1 in binary. So if the yi is 0, that will be 0 into log pi. This is the predicted value. That will be 1 minus 0, and so the value at the end will end up is log 1 minus predicted value. So end of the day, we're just finding the mean of the logs we got. And if it is 1, that will be straight up log p, the predicted values log. This is the unpredictable values log. And this one is pretty much straightforward. We here we'll have multiple cases, so we'll take the mean of the sum of the logs. That will be just y I log p. Simple. We don't have a case like this can't be a dog. You want a dog. There are multiple choices here. So let's solve a problem. And before that, you need to understand a simple thing called 1e minus 7. We'll use this. That means, in simpler terms, 1 into 10 power minus 7. That will be 1 millionth or something. This is used to avoid zero values in the softmax values we got, because basically log 0 is infinity. That means the model is stuck and the model value loss can't be reached. So to avoid this, in the softmax values, we'll clip this. So let's say we have 1, 2, but I want to avoid this 0. So I'll use the 1e minus 7 as the limit. And if it is greater than this, I'll replace this with this 1e minus 7. And so basically, this is the thing. And we need both values, 1e and 1e minus 7, so that we are on the good side of both the things. And let's solve a problem. Before that, let me clear this out so that it will be quite easy to understand. 1e minus 7 is the value we got to avoid infinity errors. And now we'll clip the values. Ypred is the array we have, and you can use np.clip and take the ypred as the value, and the limits are from e comma 1 minus e. So these are in between the limits. I adjust this array, and let's arrive at the result. That will be a straightforward mean of y true. So true value multiplied by the log of y predicted value. To this, we'll add the 1 minus y true. That means the value not happening, to the log of 1 minus y pred. And let's return the result. But we need to round it up to 4. That will be written round res comma 4. And in the next one, up to the first two parts, that's the same thing. And here we'll make the mean. But as we remember, this handles 2D values. That means more than one value, but the true value is same. So that will be np.sum y true divided multiplied by the log of y pred. But we are doing this for an array, so the sum will be np.sum. And basically, np uses something called broadcasting, so I need to define the access as 1 to show this as working. Yeah, basically we did something wrong here and we got some wrong values. Yeah, we should use np.log. np.log. And here also, let me change this to np.log and this to np.log 2. Let's run this up. Still we got wrong answers, but case 2 is working. Case 1 must be some indentation issue. No, yeah, here we need to add a minus, basically the first thing. So we got a solution here. So this is about cross entropy loss. Please go through this, and don't forget to understand what softmax is. So, and also thank you for watching, and have a nice day. Please like, share, and subscribe.